React hooks are one of the most important things to know when building applications with React. It revolutionized the way developers approach the task by enabling functional components to have state and lifecycle methods. So let's explore some of the most important React hooks, from basic state management to advanced optimizations, as fast as we can so you can start using these invaluable little tools, starting with the useState hook is the foundation of managing state in functional components. It allows you to create and update state variables in your component without needing to convert it to a class component. Here's a basic example using useState. Looking here, the useState hook initializes the state with 0. The setCount function updates the state whenever the button is clicked. The updated state, or count, is re-rendered into the DOM, making this hook perfect for tracking simple data like counters, form inputs, or toggles. As important as this is, though, you've got to see the next one we got. The useEffect hook is essential for handling side effects such as data fetching, subscriptions, or manually updating the DOM. It's a powerful tool for ensuring that your application interacts with the outside world at the right times. Here's a basic example of useEffect. Here, useEffect fetches data from an API when the component mounts, i.e., only once. The empty dependency array, or the square brackets, tells React to only run this effect after the initial render. This hook is vital for side effects like data fetching, event listeners, or animations that depend on the lifecycle of the component. This is all well and good, but what happens if you want to clean up a bunch of junk? Sometimes you want to clean up side effects, especially when your component unmounts, or rerun them only when specific values change. You can control these behaviors with useEffect dependencies and cleanup functions. The useEffect hook sets up a set interval that logs tick every second. The cleanup function ensures that the interval is cleared when the component unmounts, preventing memory leaks. This is crucial when dealing with timers, subscriptions, or other resources that need to be cleaned up, but doesn't address the very important issue of managing something even more important: the global state. The useContext hook allows you to access global state without passing props down through the entry level of your component tree. It's particularly useful when you need to share data between deeply nested components. Here's an example of using useContext with a simple theme switcher. Here, theme context holds the global theme state. The useContext hook allows the theme switcher component to access the current theme and the toggle theme function without passing props through every level. This is ideal for managing global state in applications, especially for things like themes, user preferences, or authentication, but not great if your component suddenly decides to re-render itself over and over again, which is where we're going next. Sometimes you may have a performance issue where a component re-renders unnecessarily. The useMemo hook helps optimize performance by memorizing expensive computations so they are only recalculated when their dependencies change. Here's an example of useMemo in action with a Fibonacci calculator. In this example, the Fibonacci sequence is calculated using useMemo. The computation is memorized, so it's only recalculated when the num value changes. This prevents unnecessary recalculations on every render, improving performance for expensive operations. But there's also another way to handle this. Similar to useMemo, the useCallback hook memoizes functions to prevent unnecessary recreation of event handlers or functions when components re-render. It's particularly useful when passing functions as props to child components. Here's an example of using useCallback. We can see here useCallback is ensuring that the increment function is only recreated when the count value changes. This prevents the button component from re-rendering unnecessarily. React.memo is used to further optimize the button component by preventing it from re-rendering unless its props change. But what do you do if you have a lot of states that are more complex? When this happens, useReducer provides an alternative to useState by giving you a more structured way to handle state transitions. It's similar to Redux, but it's built directly into React, which is pretty neat. Here's an example of using useReducer for a counter with multiple actions. In this example, the useReducer hook manages state based on actions: increment, decrement, and reset. This approach is more scalable than useState when managing complex state transitions, making it ideal for larger applications or more complex state logic. But there's something more we're missing here. The useRef hook allows you to persist values values between renders without triggering a re-render. It's most commonly used for accessing DOM elements, but it can also hold any mutable value you'd like. But here, we'll just put some random thing in there instead. Here, useRef is used to store a reference to the input element. When the button is clicked, the input is focused without re-rendering the component. This is a common use case for useRef when working in forms or managing focus in applications. Next, the useLayout effect hook is similar to useEffect, but it runs synchronously after all DOM mutations. This hook is useful when you need to perform DOM measurements or manipulate the DOM before the browser has painted the next frame. Here, the useLayout effect captures the width of the div before the browser repaints. This makes it ideal for cases where you need to measure or manipulate the DOM layout directly after changes, such as when building drag-and-drop UIs or responsive layouts. But we are forgetting the most important thing here. What happens when your code inevitably stops working for some reason? UseDebugValue allows you to display custom information in React DevTools, which can be helpful for debugging custom hooks or components. It doesn't actually affect your application's logic, but can provide some useful insights during development. In this example, UseDebugValue shows either online or offline in React DevTools based on the user's network status. This hook is especially useful for debugging custom hooks, which can give you some additional context while you're hacking away at that code. Now let's optimize. Debouncing is an optimization technique used to prevent a function from running multiple times in quick succession. You can implement debouncing with React hooks like useCallback and useEffect, which is especially useful when handling events like search inputs or window resizing. In this example, useCallback ensures that the fetchData function and the hypothetical thing it's fetching here is not recreated on every render, and useEffect applies a debounce by setting a timer that delays the API call for 500 milliseconds. This is perfect for preventing unnecessary API calls when the user is typing in a search bar. Only issue is, what if they want to resize the window? One of the most important things you'll have to learn is to be able to dynamically adjust window size. You can use useEffect to track window resizing and adjust your components accordingly. The useEffect hook listens for window resizing events and updates the window width state accordingly. The cleanup function ensures that the event listener is removed when the component unmounts, avoiding potential memory leaks. This is ideal for responsive layouts where the UI adjusts based on screen size. But what if you, and the page you're working on, want to do more? Scrolling, infinite or not, is one of the most important things to implement in an application, but you're going to need to track the scroll position to effectively implement it. By combining useRef with useEffect, you can easily track and synchronize the scroll position in your application. The useRef hook here tracks the div element, and useEffect sets up an event listener for the scroll event. The scroll position is synchronized with the component's state, providing real-time feedback on the current scroll position. This pattern is commonly used for scroll-based interactions or infinite scrolling features. But what if instead of multiple things on your screen, you have multiple states you need to handle? UseReducer can help by centralizing your state logic in that case, by synchronizing multiple states. This becomes particularly useful when handling more complex state transitions that involve multiple variables. Here's an example of managing a form's state using UseReducer. Here, UseReducer simplifies managing the form's multiple state variables. The update field action updates the corresponding field in the form, and the reset action clears all the input fields. This is especially useful in more complex forms or when handling nested states. Now, let's work on making sure the data persists across sessions. One way to achieve this is by storing state in local storage. With useEffect, you can synchronize state with local storage, allowing data to persist even after the user refreshes the page. Here's how to store and retrieve state in local storage. In this example, the state is initialized by retrieving the value from local storage, given it exists. The useEffect hook listens for changes to the name state and updates local storage accordingly. This technique is useful for persisting form data, user preferences, or application settings across sessions. But there's another thing we're forgetting about here. Sometimes you need to manage complex async states, such as data fetching or error handling. By combining useReducer and useEffect, you can manage loading states, errors, and fetched data in a much more structured way. The useReducer manages multiple states related to data fetching, including loading, error, and the fetched data itself. The useEffect hook triggers the API call, and the dispatch function updates the state accordingly. This is an efficient way to manage asynchronous state, especially in applications that rely heavily on API requests. But what if the component's state relies on another piece of state? In such cases, you can optimize the performance of your component by using useMemo to compute the derived state only when the original state changes. Here's an example of computing a derived total. useMemo ensures that the total price is only recalculated when the item's array changes. This prevents unnecessary recalculations on every render, optimizing the performance of components that rely on derived state, such as shopping carts, tables, or charts. And there you have it, React hooks, short and sweet. If you forget any, there's a free cheat sheet in the description of the video. From simple state management with useState to complex state handling with useReducer, hooks unlock new possibilities for building efficient and scalable applications. So go try some of these guys out.